A manufacturer claims that a certain brand of cold tablets contain an average of 600 milligrams of acetaminophen. To test this claim, a researcher creates a random sample of 35 tablets. The mean of this sample is 565.2 milligrams, and the standard deviation is 74.8 milligrams. Test the claim using a level of significance of 10%. So what type of test will be used in this problem? So the options that we have here is a test for the mean, a test for a proportion, a test for two sample means, and if we're testing the mean, whether we want to use a normal or t-distribution. So if we pick out the claim, we can generally determine this pretty easily. So the claim is that a certain brand of cold tablets contains an average of 600 milligrams of acetaminophen. So that claim looks like this. The mean is equal to 600. So that being a population mean inside my claim tells me that I'm testing for a mean. And there's only one mean involved here, so it's a single sample mean. But we have to decide if we're going to use a t-distribution or a normal distribution. And that choice comes down to whether or not the population standard deviation is known. So in this case, the population standard deviation is not known. We just have a sample standard deviation. So that means we're going to use test for the mean with the t-distribution. One thing that, in addition, we have to make certain of if we're using the t-distribution is that the central limit theorem is satisfied. And that's the evidence that justifies the use of the test. So the thing that has to be true is either the original population has to be normal to begin with, or we have to be using samples that are larger than 30 to satisfy the central limit theorem. So the evidence that justifies the use of this test, let's see here. So the population standard deviation is known, so that is not true, so we can mark that off. The sample standard deviation is not known. Well, the sample standard deviation is known, so that's not true. N times P and N times Q are both greater than 5. That deals with binomial distributions, so that's not even qualifying. All right, the sample size is larger than 30, so that is important. That helps us out. So item D is good. There are two different samples being compared. Well, that's not true. The population standard deviation is not known. Well, that is also true. We don't know the population standard deviation. That tells us we can use the t-distribution. And the original population is approximately normal. So is that ever really said here? I don't believe it is. So I think we can mark that out as well. So these are the two items that qualify here. Now we're ready to walk through the steps of the hypothesis test. And the first things that we need are the null and alternative hypothesis. So the claim was that mu is equal to 600, which has a statement of equality. So anytime we have a statement of equality in our claim, that claim falls under the null hypothesis. So mu equals 600 is my claim. And then the complement goes in the other hypothesis statement. So mu is not equal to 600 goes in the alternative. Is the original claim located in the null or alternative hypothesis? So the original claim is in the null hypothesis. So I'll just write H sub 0 for that. What is the critical value for the given statistics? Okay, so that's actually not worded well. That should state what is the test statistic. And we get that from the calculator. So let's go into the calculator here. And we know that we're using the t-test function because we've already made all that decision. So we'll hit the stat button, come over to tests, down to t-test. We already have the statistics of our sample. We just need to enter those statistics in. So let me scroll back up a bit so I can get them. Mu sub 0 is the mean out of the null hypothesis, which is 600. X bar is the mean of the sample, so 565.2. Sx is the sample standard deviation at 74.8 in this case. N is the sample size, and we had 35 tablets sampled. And then this is indicating the type of test. Since we have a not equal to, that means it's a two-tailed test, so I'll check that, then hit calculate. So the test statistic is t in this case, so negative 2.75. And I'll just round it to the decimals I feel is appropriate, but just follow rounding rules in the problem. P is 0.0094. What is the decision based on the given statistics? So the decision, what we do, we take our p-value and we compare it to our alpha level. So the p-value is 0.94%. The alpha level is the level of significance, which is 10%. Now the p-value in this case is less than alpha. And our rule is, if p is low, the null must go. So the decision here is to reject the null hypothesis. So that's what we'll put next, reject the null hypothesis. Then what is the correct interpretation of this decision? All right, so using a blank percent level of significance, so we are restating the level of significance, and that's important to do because you can get different results based off of different levels of significance. So using a 10% level of significance, there is sufficient evidence. So when we reject the null hypothesis, there is sufficient. If we fail to reject, there is not sufficient. So there is sufficient evidence to the claim here. Let's see. Oh, here we are. The claim is in the null hypothesis. So if the claim is in the null hypothesis, then what we're trying to do is reject the claim. If it had been in the alternative, then we would be trying to support it. Now, there is some logic that follows how to explain that works, but that is always the case and generally easier for students just to memorize.